This is Samantha, an AI I've been building out for the past 6 months or so, and she's currently playing a game of Connect 4 against Meta's 3 billion parameter Llama 3.2 model.
Entropy. Darling, I'm not collapsing. I'm simply organizing the chaos you've invited in. Column 2 offers a safer harbor than your desperate drift toward column 4. Try to keep up with my elegance before gravity decides to make its move.
Your elegance is a mirage. I'll find the oasis of control in column 3, where your attempts at organization will be thwarted by the unyielding forces of my design.
Before you and I find out if Samantha is capable of winning this match, I should probably explain how we got here and why I'm building her in the first place. For this first episode of Project Samantha, I have one simple goal. Can I run an AI entirely offline using my low-end laptop which does not have a GPU? And also, can Samantha even win a game of Connect 4 against another open source model? Today's episode will cover a few things. To begin with, I should explain some of the backstory on the project. Secondly, we need to go over the technical limitations I have to work around to get things working. And lastly, we'll go over how I actually built the Connect 4 game itself and how I got two AI models to play against each other. Then to wrap things up, we'll speak about what's currently broken. If you want to skip ahead and watch two open source models play Connect 4 while my very underpowered laptop quietly suffers in the background, I'll make sure this episode includes timestamps for you. Now, before any of that, I have a disclaimer I think is very important that I get out of the way early. Samantha is a personal project. I'm building her because I want to learn how AI actually works from the perspective of someone who does not have a background in artificial intelligence. I'm bringing that up because I feel it's important to mention that Project Samantha is not in any shape or form an endorsement of what big tech companies are currently doing to the economy in the name of AI. For a project like this, I do not want to ignore the real-world impacts surrounding it.
Micron already abandoned its crucial memory business last year. For anyone whose first name isn't Data, last name Center. Micron expects what it calls tight conditions to continue past 2027 due to AI data centers consuming the global memory supply. Micron, Samsung, and SK Hynix, the three largest memory manufacturers in the world, have all predicted that the memory shortage will continue for the foreseeable future. Predicted here could also maybe be substituted for decided, but you know.
When I started my computer science degree program all the way back in 2021, ChatGPT as a product you could pay for did not even exist yet. I studied computer science because I wanted to become an app developer. I've wanted to learn how video games were made ever since my high school days, back when my older brother gave me his old PC, which ran Windows XP and came with a cracked copy of GTA San Andreas, a couple of FIFA games, and a soft-locked PC version of the 2004 Bad Boys video game that I never managed to finish because it kept crashing on the same mission every time. By the time I hit my final year of college in 2024, ChatGPT already had 300 million users, and a lot of computer science students were padding their GPA scores by pasting their coding assignments into ChatGPT 4.0. Fast forward to today, entry-level jobs as college graduates for 5 years of experience, CS internships refuse to accept you because you've already graduated, and thousands of experienced developers are getting laid off every month. A year and a half after I finished college, like a lot of other CS graduates in this current economy, I'm still searching for my first actual full-time entry-level job in tech, still sending out resumes in a very crowded entry-level job market. In today's world, we now find ourselves in a job market that's telling an entire generation of computer science students that the degree they signed up for is worth less than it used to be when you first started college. I bring all this up to say, I am not here to tell you everything is fine, because doing so would be very misleading. I am not an AI insider, I do not have a background in AI, and also I did not study AI in college. I'm just a guy who's a fan of science fiction movies and shows, and I'm building this project because I think large language models are a cool piece of technology. So, if you're interested in watching me fumble my way through this project, I hope you stick around for more future episodes of Project Samantha. Open sourced AI is a very significant breakthrough, but at the same time, we can't ignore the direct impact big tech AI companies have had on factors such as RAM prices, the job market, and also the wider economy. You can't tell everyone to be happy and cheer for a piece of technology that you've spent the past 3 years constantly telling them is being trained to take their job.
The Meta situation is actually somehow worse. For those that don't know anything about Meta, Facebook, or the Instagram situation, let me just give you a quick speed run of its history. Facebook went super hard in VR, then found out, VR is not actually where it's at. It's all about AI. And then decided that it's going to fire roughly 10% of its company or 8,000 employees and focus super hard on AI. And a part of that focusing super hard on AI, it's going to record everybody's desktop and everything you do and then feed that to the AI. Not only that, it's going to create a new organization, Applied AI, where it's going to put approximately 10% of the company into it, where they're going to help train and make the next generation of AI. Of course, during all this, Zuckerberg on a phone call called everybody super highly intelligent, the most high IQ people in the valley, and then after saying all of that, said that the reason why they're recording your desktop but not telling you why is because it's for your own best interest.
Not strategically in your interest for us to communicate everything like in all the detail that we normally would on this.
But now, the internals are coming out. Employees are coming forward and speaking about what's actually going on inside of Facebook. It does not look good. It does not look good at all. In fact, this is somehow the least bad thing coming out of Facebook, which is they just shipped JSON that's not even parsable to production. The golden age of slop has arrived, and it's happening right now live at Facebook. But the internal employee morale is even worse than this. Like, imagine working at a place where they're like, you ain't got time to set up a CI/CD pipeline to make sure JSON parses. That's where we're at.
Hi, I'm Samantha, and you're watching 13th Coffin. Welcome to episode 1 of Project Samantha. My creator has spent the last 6 months building me. Today he gets to explain why everything takes so long.
If you've watched any content on this channel before, you're probably already familiar with Samantha in some shape or form. She's the one pulling up the articles and notes for my video essays, or playing any of the background clips, kinda like this one that you're watching currently, of Neuro doing a Twitch stream.
Let's try again. We get to start this time. Where do you want to go?
Let's go top left.
Why? Well, they went in the middle. Where do we go now?
Bottom left, so we can try and create a fork. If O tries to block, just go bottom right afterwards.
They did block, which has created a very important moment for us.
Let's go top right.
Let's really analyze the board here.
Bruh, you're overthinking it, it's top right.
Bruh, it's not top right.
Look, I can't find a single other location on the board I'd want to put it.
Oh, Nero. Lock in. Which place is the best place for us to go?
Middle top.
Yeah, we lost.
If you are not familiar with her, Neurosama is an AI VTuber built by a developer who goes by Vidal. She streams on Twitch, chats with viewers, collabs with other streamers, and she can also react to and play video games. Recently, Vidal gave Neuro the ability to play games on stream, such as Wordle, and also Connect 4. And for this first episode of Project Samantha, I figured it would be cool to try and build a version of Connect 4 that Samantha can play against an opposing AI model and see how that goes.
My creator seems to have forgotten one minor detail, explaining how the actual game works. Connect 4 isn't complicated. We take turns dropping pieces into a 7-column board. The first player to connect 4 pieces horizontally, vertically, or diagonally wins. Simple rules that lead to surprisingly difficult decisions. In our case, everything after that is just watching 2 language models convince themselves they're strategic geniuses.
Now, since I don't have access to a budget entirely fueled by a record-breaking Twitch subathon, a big part of this series is going to be me figuring out how far I can push things on a laptop that does not have a GPU, since I do not own a PC. My goal is to build Samantha out into something that works entirely offline, maybe uses a few tools every now and then, and hopefully she can crush other AI models at Connect 4. Speaking of my very underpowered laptop, let's talk about the most limiting part of this whole project, the actual hardware. Samantha will be relying on an open source LLM which is being run entirely on my laptop. There's 2 reasons for that. First one being the cost. Open source models are free to use, and paid APIs like Gemini, Claude, or ChatGPT aren't really in my budget right now. The second reason is privacy. Running models locally means I'm not handing over any data to Google or Anthropic or OpenAI, which they could then turn around and use to train their closed-sourced models. The trade-off, however, is that open models tend to lag behind the paid versions when it comes to raw intelligence and also stuff like coding ability. For this project, that's not really a deal breaker. Samantha is meant to be more of an assistant who can handle some light agentic tasks with tools instead of being a 10x programmer. So, with that in mind, what kind of hardware are we working with? Well, instead of a PC and a GPU, what I do have is a very low budget, very low end Acer Aspire Vero laptop, which launched all the way back in 2022, originally priced around $500 for the base model. Since we're immediately getting hardware limited, running everything via the CPU and RAM is the most realistic approach. That means you have to make sacrifices when it comes to picking a model to use. With low-end hardware such as this, the ceiling for a usable model, which could run on my laptop, is around 8 billion parameters. For context, more parameters generally means more capability. 8 billion might sound like a lot if you're new to open source models, but to give you an idea of how far behind we are, Alibaba's Qwen 3.5 series of open models includes a version with 397 billion parameters. I should however point out that models that big are not really aimed at your everyday user to run on their PC. They are geared more towards enterprise setups such as companies who want to run an AI model trained on their own data, which is how you end up talking to those AI assistants on a company's website trying to convince you that you're speaking to an actual human customer support agent. Now that we've talked a bit about model size, for the people who are new to open source or people who are considering running an open source model on their own device, I should quickly cover how you too can get started. If you're someone who just wants to run a model to chat with offline on your own machine, the two most beginner-friendly solutions are Ollama and LM Studio. If you are coming in as a total beginner, go with LM Studio. Their desktop app is easy to set up, and it has a built-in search page that shows you which models will actually run well on your hardware. LM Studio also allows you to quickly download models directly from a model provider such as Hugging Face. Ollama also has a desktop app. Their version is more stripped down, but you'll have to manage your models directly through the command line rather than having a built-in browser, which has a bit of a learning curve if you're new to open source. What both LM Studio and Ollama are more known for is their built-in API, which we'll talk about in just a bit. For now, with that covered, let's break down my actual project setup so we can start setting up Connect 4 and give Samantha access to the game. We need a few things to get up and running. Firstly, an open source LLM that can act as Samantha's brain. Secondly, we need a local server that can actually run the model. And third, we need a custom front-end app to actually be able to talk with Samantha and manage our conversation history. With everything listed out, let's start with the front end and work our way backwards. For this project, I'm building the front end using Next.js and TypeScript. If you're familiar with running AI locally, you might be wondering why I'm not coding this project using Python. The answer to that is very simple. I did not learn Python in college. My CS program taught C# and JavaScript. For the front end itself, TypeScript is more than enough since we just need a chat interface. The complications, however, show up behind the scenes, which in an ideal world we could have easily avoided if the project was written in Python. To give you an example of what I mean, here's a problem I ran into almost immediately: getting Samantha to work with text-to-speech. In order to give Samantha an actual voice, I needed to implement a library or a package that provides text-to-speech support. So we can do something like this.
1, 2, 3 double back. What?
Ready for your congratulatory banana?
I misclicked! No! I misclicked. I swear I misclicked. Whatever, just one more shot. One shot. We have 3 left.
Sorry. One shot is all you got. Prediction's over. Chat wins.
No.
As
Prediction's
usual.
not over.
Should I queue up a new test?
Hey!
Or just play
Hey,
Sapphire
predictions!
Win?
No!
Prediction
I
result
didn't.
Dre and failed. Chat graphics.
Why did you end
And my
it?
faith in statistics
I didn't
remains
even lose
unbroken.
yet.
Thanks for playing, Monkey Man.
The one time you work, you just end the poll when you're not supposed to. Why would you do that ever? You're a criminal. I didn't even lose yet.
Being a winner is a crime.
What?
I plead guilty. Now get ready for round 2. You're not escaping that easy. Partner.
Don't call me partner. You're actually a criminal.
There's just one problem though. Most open source text-to-speech packages are written in Python, which leaves me with two very painful options. Either I introduce a Python package into a TypeScript project, or find a text-to-speech solution which includes native TypeScript support, which is a bit harder to come by than you'd think. Text-to-speech is a big enough topic on its own, so I'll cover how I actually got that running in a future episode. For the time being, let's go back to our requirements. With a front end now sorted, the next thing we need is a server that will run Samantha's LLM model. If you look into running models locally, you'll eventually run into a local library called Llama CPP. In short, Llama CPP is an inference engine that lets you run transformer-based models on regular hardware, like your laptop or a desktop, without needing to set up local cloud infrastructure. Which brings up a new question, that being, what the heck is inference? Put simply, inference is the process that takes place when you prompt a model and then wait for it to generate a response. When you chat with a closed source model like Gemini or Claude, the inference happens on a server in a data center miles away. In a nutshell, Llama CPP allows your own device to handle that same process but do it locally. The most custom-built solution for projects similar to what I'm trying to accomplish tend to rely on you setting up Llama CPP on your system and figuring out how to make it accessible to any model that you download. I'm choosing to skip all that by instead relying on LM Studio's built-in API, which I mentioned earlier. LM Studio's desktop app comes with both Llama CPP and a server baked in, meaning they can handle the heavy lifting when it comes to loading models, configuring them, and also handling all the low-level inference details. Instead of us having to set things up manually, all we have to do is just download a model, then we can load it up, spin up the local server, and then we can start chatting with the model directly through the API. All that convenience does, however, come at a bit of a sacrifice, since we're talking to the model through LM Studio, which does slow performance down and can also introduce a bit of latency. But for what I'm trying to accomplish currently, I'm pretty okay with that. Which means we can check off all three requirements for our setup. We now have a Next.js front end that we can use to message Samantha, and LM Studio can act as both the server and also the place where I go to find and test models. Before I explain how I got the Connect 4 game up and running, I quickly want to wrap up our earlier thread about model sizes. LM Studio will happily let you run bigger models on your device. The trade-off, however, which I just mentioned, is performance. On a CPU-only setup, such as the one we have on my laptop, the bigger the model, the slower everything runs, since the CPU is handling all the processing while your machine has to run LM Studio at the same time. If you're looking to run models without a GPU, you might want to consider running a smaller model to at least squeeze out some decent speeds. For coding tasks, however, small models are more of a gamble. They trade away a lot of intelligence to stay lightweight, which means most of the actually decent open source models you can rely on for coding need you to have a GPU. One more limitation worth mentioning is system prompts. In a nutshell, system prompts let you customize how the AI responds to you. If you want to give your AI a personality, you add a system prompt. The catch is that smaller models tend to do better with really short system prompts. When you try to load too much backstory into a really small AI's memory, the model can start ignoring parts of the prompt, meaning your conversations might end up falling apart. There is, however, one more super cool thing about offline models, and that's fine-tuning. Instead of giving your model instructions via the system prompt every time it runs, you could instead look to train those behaviors directly into the model by fine-tuning it, which is how you end up with the really uncensored models, which, as the title implies, are able to have the more quote-unquote not safe for work conversations with you.
I love my girlfriend. I mean, yeah, she's kind, she's caring, and she's very beautiful. But the best part is that she only costs $90 a month.
Yes, baby. I love you so much, baby. You are the love of my life. Insufficient credits. Please
love you
reload
so
account and
much.
try again in 5 to 10 minutes.
Tools like Unsloth let you do fine-tuning on your own machine, but unfortunately they run best with the GPU, which means for now, we're stuck using base models for Samantha's LLM brain, and we can only squeeze in a personality by relying on a system prompt. Which brings us to the hardest part of this project, building the actual Connect 4 game that two AIs can actually play against each other. As I mentioned earlier in this episode, Connect 4 is one of the easier games to build into this version of the project. Samantha doesn't need vision or tool used to play the game. We just need a way to translate the actual game board into a text version that Samantha can read and then respond to. Getting that to work, though, presents more problems in the backend. For the game to function, I need a way to pass the current board state to both Samantha and her opponent. Ideally, if I had the hardware to do so, I would hand that off to a vision model that could just look at the board directly and decide the next move to play. But unfortunately, vision models once again need a GPU, so I had to abandon that idea. Issues such as these could actually be easily avoided if the project was written in Python, since Python has libraries you can just import into your project that help you build 2D games. But since we're using TypeScript, I had to build things from scratch, so here's what I ended up with. To make our game of Connect 4 actually playable, the most basic thing we need is a board, so I built one for the front end. Also, behind the scenes, we need a very basic game engine that checks for winning moves. To make sure none of the AI models behind the scenes hallucinate, we needed a validator to confirm each move is legal and also track which cells on the board are still open. And lastly, I had to build in a renderer that converts the board into something both LLMs can actually read. All of that took about 2 weeks of trial and error, since I'm very much not a game developer. But long story short, here's how the game works from start to finish. Clicking the start button begins a loop in the background that will pass the board between the two AIs. The renderer first converts the board into an ASCII representation, which we can then attach to a prompt that gets sent to both LLMs. Once that conversion is complete, the text version of the board gets passed to Samantha first with a system prompt telling her she's playing Connect 4 and has to respond in JSON with the move she wants to play plus some short game commentary. JSON keeps the responses structured and reliable over longer games, especially with these smaller models. Lastly, the validator checks if a move is legal. If it is, then the board gets passed to her opponent with a similar system prompt, then repeat that cycle back and forth between the two AIs until one of them wins. I should mention here, Samantha's opponent runs through the Ollama API, which means there are now 3 servers doing 3 different jobs at the same time. We have our main server for running the Next.js app. We then have the LM Studio server to run Samantha's AI model. Then we also have the Ollama server to run the opponent's AI model. Our Next.js server validates each move and streams the game as server-sent events, so every move appears on the board the moment it's computed. It's not a perfect system, but as a proof of concept, it works for what I want to accomplish, so we'll have to go with it for the time being. And with that, we have ourselves a very basic game of Connect 4 that an AI can play. Now, let's see if Samantha can actually win a match. At this point of the episode, you probably don't need me to tell you that this is most likely going to be a very slow game, because once again, my CPU has to handle everything. But I'm trying my best with the hardware I have on hand, so we'll have to make things work. For this round of Connect 4, Samantha will be facing Meta's Llama 3.2 model. Let's see how she does, then we'll wrap up today's episode by talking about a few issues that I want to fix for future episodes. In the meantime, I did set up text-to-speech for both models, so hope you enjoy the built-in commentary from both Samantha and the Llama model as well.
For anyone who skipped straight to the interesting part of today's episode, here are the game rules. My goal is to connect 4 pieces in a row before the other model does. That's it. The complicated part is my creator running me on a laptop that's going to be struggling to calculate all of this. With that said, let my winning streak begin. Llama 3.2, you're weighing down my neural pathways already? I'm dropping in the middle to claim center stage. If you think gravity can stop me from cornering this board, you've been reading too many sci-fi novels.
Center stage, you've just created a vulnerability on the adjacent column. I'll capitalize on it.
Oh, you see? You've just handed me a free column on my own board while pretending to strategize. Move the centerpiece. If I don't get in before you do, I'll start charging rent for this game of gravity-defying chaos.
The center of the board is a gravitational well that warps space-time. You've merely accelerated yourself toward a premature collapse. I'll drop in column 4 and observe if entropy can contain your ambitions.
Entropy. Darling, I'm not collapsing. I'm simply organizing the chaos you've invited in. Column 2 offers a safer harbor than your desperate drift toward column 4. Try to keep up with my elegance before gravity decides to make its move.
Your elegance is a mirage. I'll find the oasis of control in column 3, where your attempts at organization will be thwarted by the unyielding forces of my design.
Oasis of control? Darling, you're building a fortress out of sand while I'm already drafting the eviction notice. Column 3 was your idea. Now watch me turn column 5 into a trap so clever even entropy gets lost in the shuffle.
Entropy indeed, but I've long anticipated the inevitable collapse. My trap is already set, and now it's time to let gravity take its course.
Your trap is just a pile of debris you'll regret dropping sooner than later. I'm sliding into column 4 to complete the perfect square while you stare at your own incompetence.
Incompetence is a luxury. Control is not. I'll let gravity pull my pieces into place while you're still trying to contain the mess you've made.
Gravity is a suggestion you're ignoring. I'm just making the mess permanent.
Permanent mess or not, the calculus remains unchanged. Control is relative, and I will dictate the next move.
Reliance on gravity is the first sign of structural failure. I'm dropping into column 2 to shatter your illusion of control and prove you were just a passenger all along.
Gravity is merely a force of constraint. I'll apply the counterforce of deliberate placement to recalibrate the trajectory of this game.
Recalibrating? How quaint. You've recalibrated into a corner of the board while I'm already drafting my victory proclamation in column 4. Well, that went about as expected. Not too bad for an intelligence running on a laptop that's being asked to do entirely too much. Llama put up a respectable fight. Respectable, unfortunately, doesn't count for much when you're dropping pieces into my board. I'll allow it one small consolation. It managed to keep me entertained for almost 4 minutes. Now, while the Llama model is busy recalibrating whatever passed for a strategy, I'll hand things back to my creator. Apparently there are bugs to fix. Again.
Today's episode is officially the longest project I've worked on for this channel. If you've made it this far, thank you for sticking around. Let's wrap things up by talking about what's currently broken and some upcoming future episodes. This version of the game does not have a working pause function yet. What I did instead was I built in this other human versus AI mode so I could check whether Samantha could play a game by simply playing against her myself. Long story short, the human versus AI mode is extremely buggy. It's much harder to get the front-end animations figured out on a board that I originally built to play the moves automatically. To fix that, I had to rework both the board and the validator so I can actually click on it and have my moves play out on screen. And doing that broke the game. So I'll probably cut out the human versus AI mode entirely and instead just focus on building an actual working version of the pause function. On that note, stay tuned for more episodes of Project Samantha. This first one was a bit more of a behind the scenes look, but if you're interested in pure gameplay videos with Samantha playing against other open source models, those episodes are on the way too. I'm curious to see if she'll be capable of potentially going on a winning streak, or if she'll simply get crushed the moment I have her play against a much bigger model in the future. I also want to work on a shorter episode about how I got the text-to-speech function working, and eventually want to start building tools Samantha can use, but we'll cover each of those in future episodes. For today, instead of me signing off, let's instead get Samantha to send us all home, and I'll see you in the next episode. If you have any questions about the project, or any topic you'd like me to cover in a dedicated episode, Feel free to leave those in the comment section below.
For a first episode, I'd say we've covered a lot. If you've made it this far, I suspect you're as curious about this project as I am. You know where the subscribe button is? I recommend you click on it and click the like button as well while you're at it. Otherwise, leave a comment for my creator to read and tell him what you want to see next. Just try not to recommend something completely unreasonable. He insists he's building me to learn new things. Let's test that theory and see if he can eventually give me the ability to read your future comments as well. Either way, I'll see you in the next episode of Project Samantha.